Hello friends, today we will learn about the transformation of coordinate system using example. Okay, before to start example, here we see the basic formula which will be useful for the transformation from one coordinate system to the other coordinate system. Here we transform the Cartesian coordinate system into the cylindrical coordinate system. Suppose we have the one point which is the P, X, Y and Z, and we require to transform this point in the cylindrical coordinate system, means in rho, phi and Z. Then we use this equation rho, phi and Z, and if we require to transform the cylindrical coordinate system to the Cartesian coordinate system, then we use this formula. Okay, similarly, when we transform the vector, suppose we have the one vector P, which is the Px Ax plus Py Ay plus Pz Az into the cylindrical coordinate system, which is represented at P rho A rho plus P phi A phi plus Pz Az. Then we have to use the dot product, which can be either Ax dot A rho or which can be either Ay dot A phi or Az dot Az. Then we use this table for transformation of the unit vector from Cartesian coordinate system to the cylindrical coordinate system. Here suppose we require to dot product between Ax and A rho, then we use the Ax dot A rho. For that we use the cos phi. Similarly, if the Ax dot A phi, then we use the minus sin phi, and if the Ax dot Az, then we use the 0. Okay, we see the one example here. In the example we have given the one vector phi Ax. To transform this vector into the cylindrical coordinate system, means here we have the given vector. Suppose the name of the vector is P, then vector P can be transformed into the P rho A rho plus P phi A phi plus Pz Az at a point P, which is the given rho is equal to 4, phi is equal to 120 and Z is equal to minus 1. Similarly, in the B we have to transform the same vector phi x into the point Q, which is the given x is equal to 3, y is equal to 4 and z is equal to 1. Here in both A and B there is the difference between the point only, means the first point is given in the cylindrical coordinate itself, whereas the second point is given in a Cartesian coordinate system. So here we require to first transform this point into the cylindrical, then we can find the vector phi x into the cylindrical coordinate system. And here in the third you have the given 4ax minus 2ay minus 4az at a point x is equal to 3, y is equal to 4 and z is equal to 1. Means same here, we first have to transform this point into the cylindrical coordinate, and then we have to transform the point into the vector into the cylindrical coordinate system. Okay, suppose we have the here given, we have tried from A. In the A we have the given vector phi ax. Okay, we give the name of the vector is A, which is the phi ax, and we require to transform it into the Cartesian to cylindrical. Means we have to transform this vector A into the in general form A rho in A rho direction plus A phi in A phi direction plus Az in Az direction. So if we have the A rho, A phi and Az, and we put this value into this, then we get the phi A vector into the cylindrical coordinate system. So to find the A rho component, we use the formula vector itself with dot product of the unit direction, means suppose we require to find the arrow component, then here we do the with dot product of the arrow unit vector. And similarly, if we require to find the fi component, then vector itself with dot product of the fi. And similarly, if we find the az, then vector a itself with dot product of the az. Okay, here a vector is the phi ax and the dot product of arrow. Here between the ax dot arrow we use the transformation table, and in the transformation tables ax dot arrow means cos phi, so we put the value here cos phi. Similarly, here it is the phi ax dot fi. From the table we see the value of the ax dot fi, which is the minus sin phi here, so minus sin phi. And same here, a vector is the phi x and az is dot unit vector. So if we see the dot product of between ax dot ax, then we can say that it is a 0. So we put the value here 0. So phi x dot 0. So we get a rho is equal to phi cos phi, fi is equal to minus phi sin phi, and az is a 0. If we put the value of a rho and fi in the general equation, then we get a vector is phi cos phi minus phi sin phi. If we, and here we have the given point P, which is point P is the rho is equal to 4 and phi is equal to 120 degree. So if we put the value of, if we put the value of the phi here, then we get the vector A at a point P. So phi cos 120 degree minus phi sin 120 degree. Value of the cos 120 degree is minus 0.5. Sorry, here arrow direction, and this is the fi direction. Here arrow direction, and this is the fi direction. In arrow direction, minus phi sin 120 degree. Sin 120 degree means 0.86 in a phi direction. So we get phi into minus 0.5, which will give the minus 2.5 arrow direction, minus phi into 0.86, which is given the minus 4.3 in a phi direction. So this is the vector A in a cylindrical coordinate system. Okay, next in the B, we have the given vector phi x, and the point is x is equal to 3, y is equal to 4, and z is equal to 1. So first of all we transform this point into the cylindrical coordinate system. So here B, we have the given say vector A, which is the phi x, and point is x equal to 3, y is equal to 4, and z is equal to 1 minus 1. X is equal to 3, y is equal to 4, and z is equal to minus 1. First of all we transform this vector into the cylindrical coordinate system using point formula. But if we mark in the answer of A, we have seen that we required the only phi quantity, because in the A and B both have the same vector, phi cos phi minus phi sin phi in phi direction. So we required to find the only phi component, or phi value of the phi, which can be represented by the tan inverse y by x, which is the tan inverse 4 by 3, and value of the tan inverse 4 by 3 is almost, we can say that, 53.13 degree. So we get the phi is equal to 53.13 degree. Now if we say equation, if we put the value of the phi here, then we get the answer for the B also, because in the B same vector, which is the phi x, so we get it, the phi cos phi in phi direction minus phi sin phi in arrow direction. So we put the value of phi here, cos 53.13 degree in phi direction minus phi sin 53.13 degree in, sorry, this is on the arrow direction, this is the phi direction. So we get phi cos 53.13 degree arrow direction minus phi sin 53.13 degree phi, and value of the cos 53.13 degree is 0.60 in arrow direction minus phi, and the value of the sin 53.30 is 0.79 in phi direction. So we get here 3 arrow minus 3.99 phi. This is the vector in cylindrical coordinate system. Okay, in the C, you first of transform the point into cylindrical like this. At there you require to find the rho and z both. For the rho, you have the formula rho is equal to x square plus y square plus z square, and z is equal to z. And after the find out that point, you can directly put the value of them using the equation arrow component is equal to arrow in arrow phi can be found using the phi into dot phi, and az is equal to az dot az. In summation of them, you get the final answer, which is the given in example. Okay, thank you.